I'm Matthew Pulsipher, Product Manager at DVIGear, and we're just going to be doing a 20-minute discussion today on advanced video wall and building customized digital signage applications using SDVoE. There will be a gift card giveaway for those who put their business cards in the bucket over there. It's a $20 gift card for 20 minutes of your time. So, to start things off, our product is DisplayNet. It's our SDVoE-based solution. We were one of the first adopters of SDVoE technology, and we have a lot of experience in working with the technology. It's incredible stuff. We used to sell a lot of matrix switchers, and now we've moved on to this because it was the first technology we could find that could replace the matrix switch. And today we're just going to be talking a bit about custom video walls and how they've become a larger trend in customer-facing commercial AV applications. We've seen a lot of cases where they've been used in retail. And a lot of this is due to the widespread emergence of slim bezel and no bezel wall displays. A good example are these panels that we're using here at the booth. It attracts customers, it enables new levels of engagement and interactive digital signage installations. One feature that I'll mention a bit later is how USB extension as part of the SDVoE specification can enable this even further than a traditional signal distribution app system. And because of the commercial draw factor, non-standard layouts are often employed to make independent or individual installations more immersive. Stores want to have something custom. They want to have something that draws the eye, so they'll install something a little bit different. It'll get people looking and eventually looking at their product. There are three approaches to installing a video wall. There's the hardware approach, where you have a standalone piece of hardware to generate the wall signal, like a video wall processor. And there are some advantages, pros and cons to each approach. The hardware wall processor enables the use of any HDMI source because it is a hardware-based video processor. It has very good synchronization performance because it's pulling the frame from the source and it's distributing it all internally. However, your wall configurations are limited to the device capabilities, so it may be limited. It really depends on what device you've installed, and if you want to do something different that the device cannot do, you have to replace the whole device later, as well as the output ports. If you want to expand the wall later or build something bigger or smaller, you may be either overbuying or you may need to completely replace your hardware. And finally, this gets very expensive to scale up effectively. If you wanted to do something like an 8x8 with a dedicated wall processor, you're looking at a lot of money, and it would be a dedicated unit. In most cases, it would need to be something separate from what you would run with the matrix switch. Although some matrix switches do have wall processing, it's not as limited. It's rather limited in terms of features and customization in most cases. And on the other hand, you have the software approach, where you have multiple source devices or PCs running a digital signage software that is synchronized over the network or using some other external synchronization method. And the benefits of this are that it is highly scalable because you're buying an individual unit for each monitor or cluster of monitors. You can have very flexible layouts because it's all defined in software. However, lackluster synchronization performance is a problem, and we have worked with customers who have seeked out the use of our technology to resolve this because their existing software-based solution was not cutting it. Large arrays of PCs are required near the wall. You still need to distribute the signal from those PCs. Unless you want to spend on an extended signal distribution system, you're probably going to find a way to rack those PCs up near the wall, which can limit where you can put this in a commercial installation without incurring significant additional costs to extend the signal. There's no flexibility with the source devices. You can only output to the wall what the software is capable of outputting. You can't plug an HDMI source into this wall. That can significantly limit some of the applications that you may want to do. If you want to change your content, you're beholden to the software that you've chosen to implement this wall. And finally, there's no integration with the AV distribution system beyond just control that may be there by the vendor. With that integration that we're referring to, you can't just switch your wall display over to an independent monitor because it's made up of multiple video outputs from several different computers. You can't matrix switch it. It's not integrated. The SDVoE approach allows us to have the benefits of both. As a reminder, SDVoE stands for Software Defined Video over Ethernet, but what does that mean? Well, what it means is that we have software controlling hardware. We have multi-purpose standardized AV distribution hardware controlled by a standardized API commands. And this delivers the performance of hardware-based video wall processing solutions with the flexibility of software-based solutions. And just as a bit of a tangent, we think of these boxes as transmitters and receivers, and especially for the advanced SDVoE solutions available on the market, they're really a multi-purpose box. You just have a box with a video input or a video output, you have a scaler, and you have a frame buffer. And with a bit of creativity and some technical expertise, you can achieve things outside of the standard SDVoE application list if you know how to program it. And we're going to discuss a little bit on creative things you can do with the video wall functionality using those scalers later on in the presentation. So to reiterate the way SDVoE works, we're packetizing the HDMI source signal and sending it out over the network, 10 gigabit Ethernet, with no compression up to 4K 30 and light artifact-free compression up to 4K 60. Each receiver is subscribing to the same stream and shows only the assigned video segment, scaling out to the output of the display. Now, what this means is that all of the receivers are synchronized to one signal, which enables immense synchronization across the displays down to the point where they are resynchronizing each other in the wall configuration down to the line level. And that offers benefits over the software approach that we discussed earlier, where you have multiple PCs that are synchronized via software. You don't have that hardware level synchronization that you get with an SDVoE system between the graphics cards and a PC. The benefits here are a hybrid of the hardware and software benefits because it's a hybrid system. It works with any HDMI signal. We have excellent synchronization performance with lossless quality and the direct uncompressed signal delivery up to 4K 30 and very low latency down to 100 microseconds in Genlock mode. In the wall mode, it uses the frame buffer to resynchronize the signal, so by the end of the frame you're at 1 frame of latency, but you're still at a very high level performance for a video wall processor, which traditionally uses frame buffers to achieve the effects that it outputs. It's good enough for interactive applications, which is not something that can be said for something like a software wall implementation. You have immense flexibility because it's a virtual canvas. You can define what your wall display looks like, even if it's not a physical display. And we can talk a little bit about ways you can do that in a few slides from now. But it's a virtual canvas, and additionally, every single destination display is independently routable as a part of a building scale matrix that can be achieved with sufficient 10 gigabit Ethernet routing fabric. You can go up to 8x8. There's a low marginal cost to expand. If you already have a 5x5, you can just buy more units. You don't have to replace the fabric of the switch or replace the whole processor in order to expand this system. It has advanced video processing as a result of those internal device scalers, which allow for asymmetric or even custom offset walls. And we'll detail some of the more interesting applications that we as a company have created in response to customer requests later on in this presentation. And as I said earlier, it's integrated with a building scale matrix switching system. If you have sufficient fabric, you can network all of your source devices to one network, connect these destination devices into the same network you're using to feed all the rest of the destination devices in the building. Every individual display can show any of the independent source signals routed into the system. So as a brief side here, I want to talk about how we've been able to use the SDVoE API to integrate advanced video wall processing directly into our user interface for DisplayNet. We have full support for SDVoE video walls, and our software automates a lot of the advanced functionality that SDVoE is capable of doing, such as cropping, scaling, letterboxing the source signal to accommodate exotic aspect ratios that you can see in some of these custom retail installations. Additionally, as part of our API, we offer a virtual destination device, so instead of configuring the wall every time you route a signal, you can just route the signal to the wall with one API command. And I went back. As a part of that asymmetric wall support, or advanced video wall processing as we call it, we support stretch, we support crop, and we support fit with letterboxing if you have content that doesn't fit necessarily the video wall that you've created. In this case, we have a 3-column, 2-row video wall, which is significantly wider than 16 by 9, but we're still filling it up. And with our software, there's no need for the integrator to go into any further technical detail beyond just designing the layout of the wall, dragging their destinations to the wall, choosing the display mode, and setting the bezel correction appropriately. We also support vertical video walls. In this case, we have 3 rows and 2 columns, and the stretch, fit, and crop options act exactly the same way. And the reason we included this, besides showcasing our software, which I'm always happy to do, is to show that the SDVoE API is immensely powerful. And this is just what we can do with automation. Now, what you can do if you embrace the SDVoE API directly are custom installations. The virtual canvas approach to video walls opens up many opportunities for advanced applications. You can do offset walls, walls made of portrait displays, and exotic native resolution aspect ratios, so you can have perfectly synced displays off of one video output across a unique shape at native resolution by using the characteristics of these virtual displays and by using the SDVoE API to achieve that. So we're going to go into a little bit of detail of how you can achieve these 3 things. Offset walls are demonstrated in this image. What this really is, so we have a 4-display wall, but the top and bottom rows are offset. What this really is a 2-column, 3-row wall. And what they've done is they've shifted over on the X factor the top and bottom rows right from the top left position and left from the bottom right position respectively to render the content in this custom shape which catches the eye of the customer. Because it's running the exact same algorithms and sequence as a normal video wall, we've just changed the position of the displays. It has identical performance. You still have excellent synchronization despite this custom application, and it will accept any HDMI signal. And as long as the resolution of the signal is the same as the resolution that you've configured the wall to, it will work for any device. And if you want to change resolutions, you simply have to recalculate the positions of each panel in your wall implementation, as offsets are calculated using pixel rows and columns rather than physical dimensions. Portrait walls are another interesting thing that we've had certain customers ask about. And in our testing, we found out that portrait-oriented displays can be used in walls, as shown here, where you have a portrait made of portraits, if the source device can output a portrait-oriented signal. There are ways you can do this. You can do this manually with many graphics cards and in operating systems. However, one way that you can automate this is by creating a custom EDID, sending it to the transmitter, and having that EDID presented to the source device. And in most cases, if that's a preferred resolution and you have the appropriate graphics card, the PC will output that resolution. And the functionality is identical to landscape walls. You still have that line-by-line synchronization and support for different HDMI source devices, as long as the source device is outputting that portrait format signal. Additionally, we have highly customized walls. This application was made in particular to a customer request that we had regarding a software wall. They wanted to use a hybrid of a software video wall solution along with DisplayNet to both distribute the video and reduce the number of video outputs required on their software source device. So what we were able to do is a unique synchronized wall, native panel resolution across several panels, using only one source input. So we were able to get more displays out of one video input. And the way we were able to do that was create a virtual display using a custom EDID. So by using an external EDID editor, we create a display with extended resolution in one direction and sent that as the default resolution out to the source device. The only limits that you have regarding which resolutions you can send are 10 gigabit bandwidth, and SDVoE's light artifact-free compression can be employed manually to enable further resolution extension with our 1.4 compression ratio, saving a fair amount of bandwidth as needed. And the EDID standard is limited to only 4,095 rows and columns. So as an example, we have here, we could do a stack of 3 1080p displays in a row. We've created a custom resolution that encompasses those whole displays. The source device outputs that, and we use the wall API to fill out those displays at native resolution per display with perfect synchronization off only one video output. So as a brief overview of what we've talked about, video walls are an integral element in modern digital signage. SDVoE delivers the performance of hardware-driven walls while also delivering the flexibility of software-driven walls. DisplayNet has been able to leverage that SDVoE API to make many custom wall applications straightforward and simple, including scaling and mixed aspect ratios, including portrait and extreme landscape walls. And because of the flexibility of SDVoE, you can get high-performance custom installations with additional flexibility of both software and hardware. I really appreciate you guys attending. We're doing a giveaway of the $20 gift card to whoever has their business card in the ring. Anyone want to enter?